Okay, well, next up we have Mayank Jindal. He is a seasoned software engineer with a wealth of experience. He works in microservices at Amazon, and he uses AI techniques to enhance efficiency across Amazon. Here he is with Unleashing Python's Power, Serverless Innovations with AWS Lambda.
Okay, thank you so much everyone for joining me on serverless innovations with AWS Lambda. Today I'm going to talk about introduction of serverless and how we can use AWS Lambda in Python, which is serverless solution provided by AWS. I'm also going to talk about AWS Lambda lifecycle and what are some of the performance optimizations which we can do for AWS Lambda. And at the end, I am going to talk about cost of AWS Lambda. So let's start with introduction to serverless. There has been some paradigm shift in the infrastructure management for software development in last 10 to 20 years. Traditionally, companies used to own their own big data centers where they used to own physical hardware or physical machines. And those machines were used for managing applications, serving client requests, basically as a server, and for any other computing needs. Then cloud-based servers came into the market. So it was one level abstraction over data centers. So it was basically like renting servers from third-party providers. And then serverless came in the last decade, which is abstraction over cloud-based servers. So serverless basically means that developers don't need to worry about managing servers, like creating network infrastructure, provisioning servers, doing OS patches, doing OS updates. It's just automatically managed by cloud providers. So AWS Lambda is serverless computing platform provided by AWS. There are some benefits of serverless architecture. One is, as I talked about, which is no need of managing servers. Developers just need to worry about their application code. They don't need to worry about the actual servers where their code will be run. Next is automatic auto scaling. Uh, Application developers don't need to worry about auto scaling. The serverless architecture automatically scale based on the client traffic. Third is pay per use cost, which is developers don't need to worry about paying money even when servers are not actually used. And fourth is faster time to market. So since there is going to be a lot of time saving in the development process, so it would help companies and engineers to productionize their applications faster. So Lambda is really well suited for event-driven architecture. So I will give some brief introduction about event-driven architecture. So whenever we want to execute some kind of stateless logic in response of some event, we can use serverless architecture. And it's because that we don't need to pay for servers running 24 into 7. Let's say in the entire day we get traffic only for 1 hour. So we want to only pay for those 1 hour rather than paying for all the 24 hours. So this is one of the example which I placed for event-driven architecture. Let's say we are building an e-commerce website, and every time there is some kind of order placed by customer, that order entry is placed into some kind of database. And what we want to do is, let's say we want to send some kind of order confirmation email. So we can tie our Lambda, AWS Lambda, to this database. So as soon as there is going to be a new entry into database, that DynamoDB database is going to publish an event to the Lambda. Lambda is going to listen to it, and that is going to call email service. So here I have put some kind of some Python code for working with AWS Lambda. So AWS provides Boto3 library for working with Lambda. And so the first code describes like how we can create the Boto3 client. So and this client would be used for all kind of Boto3 operations. So first operation is, let's say we want to create the Lambda function. So Boto3 library provides a function called create function, and we can pass some kind of input. So first input is function name, second input is runtime. AWS provides many runtime like Python 3.8, Python 3.11. There are some other runtimes for other programming languages. Then we will have to pass a role, which is IAM role, and it would give a lambda some kind. It will give some kind of permissions to AWS Lambda. Let's say we want to call some database or some kind of other AWS service, we can use this role. And the fourth parameter is handler. So this handler parameter would actually describe like where the actual code is. So let's say the file name is main.py file, and there is a function, let's say, called test function, and that test function has some kind of code which developer want to execute. So we can place that naming of file and naming of function in this parameter. And the fifth one is code. So that is like the gib Python code, which is having all the dependency of the Python package. And the next is, once we have created a Lambda function, we want to invoke the Lambda function. So Boto3 provides a invoke method, and there we can pass function name and payload. This payload is going to be the input for that function. So it can be, let's say, some kind of customer ID or customer email. Okay, so next I'm going to talk about AWS Lambda lifecycle, like what happens when AWS Lambda receives a request. So once it receives the request, it downloads the code from S3, which is object storage provided by AWS. After downloading the code, it creates execution environment where the Python code would be executed. Then it runs the initialization code, and then it runs the handler code. I will be talking about initialization code and handler code in next few slides. So there is a concept of cold start and warm start. So first three steps of this life cycle, which is downloading the code, creating execution environment, and running the initialization code, this is cold start. So this cold start typically happens in the first request. So after the first request, Lambda retains this execution environment and initialized code objects for some time to improve the performance. So from the second request, same execution environment is used. So this process of reusing the same execution environment is called as warm start. And this cold start typically occurs in under 1% of invocations. Let's say request is coming after long time. So AWS destroys the previously created environment. So a new environment will have to be created again. And let's say there is increased traffic. So let's say there are 10 execution environments already created, but we need 20 execution environments. So those execution environments will need to be created again. And the cold start duration varies from 100 milliseconds to over 1 second. Yeah, so next I'm going to talk about initialization code. So initialization code is the code which is placed before the actual handler code runs. So it can be like importing dependencies, setting up some configurations. Let's say we want to initialize connections to some other services. So these kind of things happen in initialization code. And this is typically the biggest impact on the duration of cold start. So if you see in this picture, like the first from line 1 to line 9 are initialization code, and the next is handler code. So the global variables which we put in initialization code, those variables are shared across invocations if some invocations are served by the same execution environment. And ideally we want to avoid global variables as much as possible, because it improves initialization performance, and it also prevents variable leaks across invocations, because same execution environment can serve multiple invocations of the function. And let's say we want to reduce cold start. Let's say we have optimized our initialization code, and even then we are having more latency than required. So we can use provisioned concurrency. So what it does is it keeps function initialized and warm, and those functions are ready to respond in double-digit milliseconds at provisioned scale. It happens because all the setup activities, all the like downloading the code, initializing the code, it is already happened before invocations. And it has some kind of additional cost because AWS has to keep all the environments always ready. So like this is the Boto3 code section which I have put to place some kind of provisioned concurrency. So if you see in these inputs, the last argument is provisioned concurrency execution. So in this example, we have put as 500. It means that 500 execution environments will always be ready to serve the request. There won't be any cold start as long as we are not having more than 500 invocations. At last, there is some cost of serverless. In general, it's not that expensive. So there are two kind of cost. One is request cost. So it is for 1 million requests, we incur around $0.2, 20 cents. And there is some duration cost. So it is 1.6 into 10 to the power 5 for every GB multiplied by second. So let's say we have allocated 1 GB memory to our function, and our function runs in 1 second. So we would incur 1.6 into 10 to the power minus 5, plus some kind of request cost depending on the number of requests. Yeah, so that was all from my side. Any question?
Check, 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 check. Okay, so does anybody have any questions? Going once? Going twice? So to the crowd with no questions.
Thank you so much. If you have any more questions, feel free to send me.